Hello, today I'm going over more electron configuration practice. And as you can tell by the title, more, this is the second part of electron configuration practice. So we did an intro one. This is doing the same thing, but taking it a little bit further. And we discussed the rules that are involved with figuring out or filling the orbitals and electron configuration. And we'll review those again this time. It talks about them up here: off-bow principle, Pauli exclusion principle, and Hund's rule. And then this is a nice little example for each of the three. So let's start with those. Off-bow principle states that we always go from the lowest energy level towards the highest. We don't skip. So this one doesn't work because we filled electrons into this S1 orbital, then we skipped S2 and went up to 2p. You always have to go from the bottom, S1, to the next one, S2, to the next one, SP. What ours is going to look like is that means we're going across. You're not going to have any boxes going across that you don't fill out. There might be some at the end that you don't fill out, but not in the middle. Okay, Pauli exclusion principle. That one's actually over here, and that one's saying that you can only have two electrons, which are the arrows, in each orbital. So we have that S, or 1s here has two, but you'll notice the one that's X'd out has them going in the same direction. That's saying that they're in the same spin, the same state. You cannot have that. They're gonna only be paired in opposite states, opposite spins. And then Hund's rule is here, and what that is saying is when we're filling in orbitals like the 2p, we're going to pick a direction like up and say one up electron, next up electron, third up electron. So we fill those up electrons in first, and then we come back and then do the down electrons if we need them. We do not do it like this where it's one up, one down, one up, one down. All right, so we're gonna see examples of all of those as we start to fill this out. Let's do the first two. Be, beryllium, is a pretty small atom, so it's not gonna take us as long. And it has the atomic number 4, which means it has 4 protons and also 4 electrons. So I'm just making my note for myself. You don't have to put that, but I'm making a 4 there so I remember there's 4 electrons. I always start at the S, or 1s, 1 electron, 2 electrons. Now I can jump over to the 2s, 1 electron, 2 electrons. So 1, 2, 3, 4, that's my 4 electrons. That's all I need. So I'm all done. Now I can write in my shorthand. And when we're doing that, we're just writing in the orbital. So I would start with 1s. And how many electrons do I have in here? 2. The only other number it could be is a 1, right? In this particular case. And then I have 2s, and also with 2. So that's it. That's my electron configuration for Be. Now let's look at phosphorus, which is more difficult. Phosphorus is over here. It's a larger atom, atomic number 15. So this one's gonna go further across. And just like before, we're gonna start with 1s, because that's the lowest energy level orbital. And we're filling across like this. Now we get to the 2p orbital, and we have this broken into 3 parts. You have 2px, 2py, 2pz. Those are the axes, like at 3-dimensional axes. So this one's along the x-axis, this one's along the y-axis, and this one's along the z-axis in a 3-dimensional space. But to fill these in, I'm gonna write my electrons going across first with up arrows. And so far I've got 4, 5, 6, 7. So I gotta keep going because I gotta get up to 15. I come back over here, write my down arrows for those 3. That gives me 4 plus 6. I've got 10 so far. Now I have the 3s and that only holds 2. So I go 1 up, 1 down. Then I get to 3p, which also has 3px, 3py, 3pz. We're going to treat those kind of as 1. And so far I have 12. I need 3 more. So to write my 3 in here, I go 1 up, 2, second one up, third one up. That is 15. If I had to keep going, then I would do down, down, down arrows. But 15 is all I need, so these are all my electrons. Now the electron configuration, the shorthand here. 1s2, because I have 2 in there. 2s2, also have 2. 2p, now I only write 2p once, and then I'm going to include all 6 of those electrons. 6. Then I have 3s, there's only 2. And then I have 3p. So between all 3 of those, I have a total of 3 electrons. And that's how you do it. You're going to go through each of these and figure out how to fill up the orbitals, how to write the electron configuration. Let me know if you have more questions. Thank you.